This tutorial is going to quickly show you a couple ways to make a surface or planes in Rhino using either curves, lofts, or starting from scratch with some dimensions. You can access most of the surface tools in the surface tools panel. The most basic form of a surface is a plane. There's multiple subcommands here. You can make it vertical or you can draw it around its center. I'm just going to make a regular plane here. It's asking me for the first corner, and then it's going to ask me for the length or the other corner. I'm just going to randomly draw here. Now in certain modes you'll see these lines that pop up on the surface. These are called ISOCurves, and they just show you that this is a planar surface and it's one whole item. And it shows you where the center of it is as well. Sometimes I turn these off. You can go to the properties for the object and you can turn show ISOCurves off, or change the density to -1, and you won't see those. Now another way to make a surface is to create a surface from an outline. Now if I have let's say a rectangle, I can use a command called PlanarSrf. Now PlanarSrf only works for curves that are closed and for curves that are all coplanar. So I'm going to run it here. I still have the original curve, but now I have a surface that's created from the outline. Let me explode this. And I'll select these curves again, and I'll run PlanarSrf. It's not going to run it because the curves do not form a closed loop. So there's a couple ways you could create a surface from this. If you want to loft from this side to this side, you can draw some curves and use the loft command. We're going to select both of them, use loft. You can ignore this for right now, and now we've created a surface, and we still have those original curves on the outside as well. These curves don't have to be exactly the same. They can be, don't even have to be coplanar. I can shift select these and I can loft, and it will essentially draw between these surfaces, or these curves. Now this could be at an angle too. Let's select both those, and then let's run the loft command, and it will try and fill it to its best abilities. I can also extrude these curves into surfaces using an ExtrudeCrv command. It's asking me for the curves to extrude, and then it shows a direction. Do I want it to go both sides? And you can type a length here. Let's make it go this way, and I want it 20 feet. So now I have a 40 foot plane. You can also run this command with multiple curves selected, so I can run ExtrudeCrv with multiple curves selected, and we'll extrude them all in the same direction. Next, I'll show you a couple commands that you can use to join or unjoin surfaces. So let's say I have these two surfaces. I know they're the same height because I extruded them to the same dimension. I'll rotate it with the gumball, and I'll move it so that their corners are touching each other. Now I know that this line overlaps on both of them. It touches both surfaces equally. So if I hold shift and I run a command called join, it says two surfaces or polysurfaces have joined into one polysurface. And now you can see that their ISOCurv density has changed to show me that it is a single object, essentially. And over here on the type it says it's an open polysurface. You can also run a command called explode, and that will tell me that it's exploded a polysurface into two surfaces. So now I have two surfaces over here, and I can modify them individually. For instance, if I have a box and I wanted to just modify this face, there are many ways, but I could explode it. Now you can see that ISOCurv density has changed again, and then I can start deleting some of these items. I can shift select and I can join them. And now they're one object again. Surfaces themselves can be modified in a couple different ways. Let's delete this and just focus on these surfaces. Let's say I want to move this edge. I'm going to run a command called MoveEdge, and it's asking me for what edge I want to move. And I'm going to hit enter when I'm done. And then it's asking where I want to move from. And now it's giving me a number on a plane, and it's constraining it to a certain dimension. Now if I hold shift, it will move it just in the Y direction. Surfaces can also be manipulated by what are called control points. Now Rhino is a NURBS modeler, it's not a polygonal modeler, and I'll have a final tutorial on the differences between the two. But essentially it means that Rhino is going to run equations to try and figure out its geometries. So let's select this surface, and I'm going to use a command called pointsOn. And what that does is now you can see the control points of the surface. These are the sort of edges that are defining the equations to fill this as a surface. If I select one of these, I can manipulate it with the gumball and create very complex surfaces very quickly. You do have to be kind of careful with this, especially if you want to avoid creating extremely complex geometries and non-developable surfaces. But one tip is you can select items that you know are going to be on the same line. For instance, these two, and you can manipulate them that way, and the surface will usually remain manipulatable. You can turn points off as well if you want to hide those. And let's run pointsOn here and select both of these. And now I know this will be a developable surface. Well, how would I create a surface where I have more control points? Well, I can use a command called rebuild, and it's asking me what I want to rebuild. I'm going to select this. It's giving me a U and a V count. So U and a V count is just a coordinate system that is based on the surface rather than the X, Y, Z. So U's are X's on the surface and V's are Y's on the surface, essentially. It's telling me how many I have currently in parentheses. So this has 2 points basically in the X and 2 points in the Y. That's why we had 4 total control points. And then it's asking me for a degree. So if you watch the curve tutorial, I showed you the difference between the degrees. This will sort of be modified by this. So if you have too few, you can't go to a maximum degree and vice versa. It's asking you for a few other options as well, like do you want to delete it or do you want to keep it so you can rebuild it and make a new object. But let's try 10 by 10. And let's give it a degree of 2. You can see now that I have my preview on, you can see it rebuilding with this grid, and now I have control points all around this surface, so I can sort of manipulate it. If you were in a polygonal modeler, essentially the control points are the polygons. So when you move this, it doesn't sort of redevelop like Rhino does, and that's why Rhino is really advantageous to creating smooth and accurate designs. So we're going to go over geometry creation in another tutorial series, and that's going to be a main focus of the class, is taking sketches and ideas and developing them into 3D digital objects. But the last thing I want to go over in this tutorial is trimming and sort of drawing on these surfaces. So if I draw a line and I know I snap to, let's say, an endpoint and an endpoint, I can run a command called trim, and it will sort of trim out the projection of that line. Now this surface wasn't developable. You can see that it has a curve there. If I draw a plane here, and I draw a line, I can select that line and I can use the trim command, just like I would use the trim command with just lines, to trim out that half. I can use a command called split as well, so it's asking me what I want to split and then what the cutting object is. And now I have 2 surfaces. I can rejoin these as well, so I can type join, and it says 2 solid poly surfaces joined into 1 poly surface, and now it's an open poly surface. I can merge all the faces as well, and now it's just a surface. It doesn't have to be just lines that you're using to trim, so let's extrude this curve to create a surface. I can trim with the surface, and wherever it will intersect, we'll cut it. So if this is perhaps maybe a little bit more complex, I can use trim. So let's select nothing, run trim again. You can see what my cutting object is. I want it to be that. And it doesn't fully overlap, so let's move this up, or you can move the cutting object down and run trim again. And I want to select this object and trim out that. And now I have a clean surface. If I try to join these, it's going to tell me that it's unable to join because they don't meet at their corners. You can also do this for very complex objects as well. So let's say I want to take this complex surface, run the trim command, and select the cutting object and trim out this. So now I have a trimmed down object.